We're going to be using the same formula that we did, the definition of the derivative that we used in 9.1. We just have a little bit more complicated problems. And so we start them the same by doing the f of x and the f of x plus h. But when we put it in, my derivative dy dx is equal to, or actually I should be calling it f prime of x because I'm using the f of x. Not that that matters too much, but is the limit as h approaches 0 of f of x plus h, so that's 1 over x plus h minus 2 minus f of x, 1 over x minus 2, all over h. If I plug in and do my limit the way that I usually want to do, I end up with 0 over 0, which is a problem, and that means that this can be simplified or cleaned up, and we do it by dealing with this complex fraction. What I want to do is get rid of the denominator. So what I'm going to do is I'm going to multiply the top and the bottom by the common denominator. And it's just the denominator of each of them. And when I do that, what happens is in the first fraction, the x plus h minus 2 cancels out. That leaves me with a limit as h approaches 0 of just the x minus 2, and in the second fraction the x minus 2 cancels out, and that'll leave me with the x plus h minus 2, but I have to remember that I'm subtracting that, so I'm going to have to distribute that through all over h times x plus h minus 2 times x minus 2, so I have to remember to bring that in on the bottom, that common denominator. So again, on the top it cancels out the denominators, and then it leaves me with something that's going to clean up a little bit nicer. So I have the limit as h approaches 0 of x minus 2 minus x minus h plus 2 all over h times that whole thing. Okay, and then cancel things out, and I'm left with on the top negative h over h, which again that allows me to cancel the h's out, so I'll be left, don't forget that negative, so I'll be left with negative 1 on the top. So I have the limit as h approaches 0 of negative 1 over x plus h minus 2 times x minus 2. Then I can take the limit by putting that 0 in, and when I take the limit, I'm done, I drop it, I have negative 1 over x minus 2 times x minus 2, or x minus 2 quantity squared. And so that is my derivative. Same thing's going to happen on the next one. Again, I have f of x. I'm going to assign the negative to the top, 2x plus 5, and f of x plus h, which is negative 1 over 2x plus 2h. I'm replacing the x with x plus h. I'm going to distribute that 2 through, so it's 2x plus 2h plus 5, and now I can put it into that formula. So f prime of x is equal to the limit as h approaches 0 of f of x plus h, that's this guy, 2x plus 2h plus 5, minus f of x, which is just the 2x plus 5 over h, and then I'll multiply the top and the bottom by the common denominator. So I'll bring that up here. Again, the common denominator is the 2x plus 2h plus 5 times 2x plus 5, and in the first one it's going to be negative 1 times 2x plus 5 minus negative 1 times 2x plus 2h plus 5 over h times that whole 2x plus 2h plus 5 times 2x plus 5. And I forgot to stick my limit in front of there. I'll put that in there, so bring this up. It's the limit as h approaches 0. And then I can start cleaning stuff up. Limit as h approaches 0, negative 2x minus 5, and then I'll make that plus. So then it's plus 2x plus 2h plus 5 over all of this, h times 2x plus 2h plus 5 times 2x plus 5. But minus 2x plus 2x minus 5 plus 5, that's going to happen all the time. And then the h also cancels out. So now I'm down to the limit as h approaches 0 of 2 over 2x plus 2h plus 5 times 2x plus 5. When I put that 0 in and take my limit, I'll have 2 over 2x plus 5, because that piece is going to cancel out. So it's 2x plus 5 times 2x plus 5, which I write as 2x plus 5 quantity squared. Okay, so those are the ones where you have rational functions. I'm not going to do problem number 3. I'm going to jump right on to the rest of them, or the other ones where they're radical functions. We won't have the same thing. It's not going to be the same issue as a rational function where we have fractions in it, but we do have the issue of it being a radical function where we're going to have to get rid of or clean up the radical to simplify. So we're going to be using that idea of a conjugate. So I have f of x. I'll do f of x plus h. So that's the square root of 5x plus 5h plus 2. Again, I'm just putting x plus h in for x, and then I distribute the 5. So that's where that comes from. And my derivative, f prime of x, is the limit as h approaches 0 of that first part minus the original all over h. Again, if I do the limit like I want to, I'll get 0 over 0, which means there's some simplifying that can be done. So to simplify, I'm going to use the concept of a conjugate. That means I'm going to multiply the top and the bottom by this radical statement, but a plus in there. So when I do that, what happens is on the top, it gets rid of the radical, but then on the bottom, I will have that whole thing, 5x plus 5h plus 2 plus the square root of 5x plus 2. So it still is kind of that ugly thing on the bottom. But again, this thing right here is what I'm multiplying the top and the bottom by. And in doing that, again, it's going to get rid of those radicals in the top. And again, I forgot my limit again. Limit as h approaches 0. I didn't take it yet. But when I do this, then I can simplify that stuff out. So I get 5x plus 5h plus 2 minus 5x minus 2 all over h times that big old ugly thing. And the 5x goes, and the 2 goes, and then again the h cancels out. So that's my whole goal, and that's what I want to do. The h is that's the troublemaker down there, that h. So now I have the limit as h approaches 0 of 5 over 5x plus 5h plus 2. Oops, that was plus. I accidentally put a minus, but that should be a plus there. Plus 5x plus 2. And then when I put that 0 in here, that term cancels out. And I end up with 5 over the square root of 5x plus 2 plus the square root of 5x plus 2. That's 2 square roots of 5x plus 2 is what I have on the bottom. And that's my final answer on that one. I'll run through one more similar problem with the radical. So f of x is the square root of 3x plus 5, and f of x plus h is the square root of 3x plus 3h plus 5, and I'll do my derivative is the limit as h approaches 0 of the square root of 3x plus 3h plus 5 minus, what are you looking for? Square root of 3x, well, I can, but somebody's going to hear me talking to you in the video. I'm already doing it, so. Were you looking for something, or did you find what you needed?
I was going to write on the board.
Oh, okay.
It's nice to hear you.
Okay,
teaching.
finally doing something?
Nice day. And then I was going to hit you over the peace sign and walk out. But now that
Uh,
you can talk, that's hilarious.
All right, so I'm going to use my conjugate again here. Remember, that's multiplying the top and the bottom by the same thing with a plus. And so when I do that, it gets rid of the radicals on the top. So that's 3x plus 3h plus 5 minus 3x plus 5. I always have to remember to put that in parentheses, so I distribute the negative. And then on the bottom, it's the h times the square root of 3x plus 3h plus 5 plus the square root of 3x plus 5. Again, I'm multiplying this thing here on the top and on the bottom, and in doing so, it gets rid of the radical on the top, but that thing will stay on the bottom. So then I can do my cleanup limit as h approaches 0. I have 3x plus 3h plus 5 minus 3x minus 5 over that whole thing. And then stuff starts to clean up, gone and gone and gone, and actually, again, the h goes, and so now I'm down to the limit as h approaches 0 of 3, that was left in front of the h, don't forget that, over that whole bottom thing, 3x plus 3h plus 5 plus the square root of 3x plus 5. Then I do my limit, cancels out that middle term, that leaves me with 3 on top, and then 2 of those radical 3x plus 5s. And you'll start to see patterns and things that happen. Oops, sorry, I need to slide that up. You'll start to see things that happen over and over again. It's, like very similar things that happen in the radical problems, very similar things that happen in the rational problems. But that's it. If you have any questions, just give me or send me an email or whatever, and I can try and do a better explanation. But hope all goes well. Have a good one.